Okay, the limitations of traditional spatial analysis. We can say that most of the GIS tools that we relied on for decades were designed for a 2D world or two-dimensional world, a world of flat maps, okay, that consists of X and Y coordinates and also horizontal boundaries. And while we could say that this approach has been effective for basic land use planning or transportation analysis, it starts to fall short when we deal with complex urban environments. Okay, one of the biggest challenges with traditional GIS is the lack of vertical context. We can say that cities are no longer flat. They are basically stacked, layered, and also multidimensional. In the cities, we have high-rise buildings, we have underground utilities, we have elevated roads, we have pedestrians, walkways, we have multi-story car parks, and many more. Yet, still, a 2D map only tells some parts of the story. So imagine trying to manage utilities or conduct evacuation planning in a high-rise district using only a top-down map, which is 2D map. You might know where things are in the horizontal plane, but you definitely will miss the critical information about the height, about the depth, and also about the vertical relationships. And the vertical dimension isn't just in the sense of architectural, but it's also environmental. So this brings us to the another major limitation, which is the inadequacy for environmental modeling. So, for example, like many of the most pressing environmental challenges, for example, like air pollutions, noise propagations, and also wind movement, it cannot be accurately modeled in two-dimensional spaces because these phenomena behave very differently in 3D space. So let's take, for example, like air pollutions. In a dense city or in a dense city block, okay, consists of tall buildings, pollutants. It's just not the pollutant itself. It doesn't not spread horizontally. Once they get trapped, they can be redirected or concentrated due to airflow patterns between buildings. So a 2D map will show you the source, but not the real impact zone. Okay. Similarly, noise pollution can be affected by building heights, wall angles, the terrain's elevations. So without the 3D context, the predictions become more generic and sometimes often misleading. Another example is the wind movements. So this wind movement which directly affects both pedestrian comfort and also building energy efficiency. So if we ignore the third dimensions, it means that we ignore how wind tunnels through narrow spaces and how it gets blocked by towers. Okay, so in short, we can say that if we continue to rely on this 2D GIS spatial analysis, we are not just limiting our perspective, but we are also compromising our planning outcomes. So that's why a new approach is needed, a one that goes beyond the surface. So a 3D understanding of space enables us to see not just where things are, but also how they interact, how they impact one another, and how also they evolve over time. Okay, so let's remember this: when our tools are flat, our decisions are often too. So to truly understand the urban environment, we need to think and model in 3 dimensions.